Welcome to Computing at Home with Digital Schoolhouse. My name is Estelle, otherwise known as ComSci Geek. I'm a computing teacher and also develop resources for the programme. We specialise in delivering computing workshops that are accessible, educational and fun. You are watching part 2 of our Shape Calculator workshop. This part of the workshop uses Scratch, so you'll need a device to take part, but don't forget, all of our part 1s of our workshops are unplugged and you can watch any of our previously streamed workshops on our YouTube channel. Just search YouTube for Digital Schoolhouse. To all learners watching, remember you can pause the video at any time to take notes, collect your thoughts or take part in the workshop alongside me. The Digital Schoolhouse team are ready and waiting in the chat should you have any questions throughout, and I'll also be taking 5 minutes to answer your questions at the end of the workshop. Parents and guardians, you might want to watch the next bit as it explains how to access our resources, but after that feel free to sit nearby or to supervise if you want to, and let's get started. Okay, so you'll find our resources via our website, which is digitalschoolhouse.org.uk. Just wait for the website to load. Go to resources, click on live workshops. Scroll down the page and find Shape Calculator. Click on the link that says Shape Calculator. And you'll find the resources are in the this area here. If you create yourself an account, you can also access extra resources for this workshop as well. There's no resources that you actually need for taking part today, but those are really if you wanted to have a go at taking this further, or if you're a teacher watching and you wanted to have a go at this with your class at home. So that's where you'll find the resources for today's workshop. Other than that, you'll need to use the Scratch website, which is scratch.mit.edu. That's scratch.mit.edu. Hit enter. Just wait for the page to load, and then you'll need to click on create. And that will open up the editor. If you enjoy using Scratch, we've got several other workshops in Scratch, so do feel free to look back through our back catalogue on our YouTube channel if you're interested in looking at other Scratch projects. If it comes up with a green box down here that says tutorial, you can close that. You don't need to have that open for today's workshop. The other thing that you're going to need to do is to access the pen tool. And to do that, you need to click on this little area down here that has the little blocks with a little plus next to them, because we're going to add some extensions. And the extension that we're going to add is the pen. So click on the pen and that will add the pen blocks to what you have available to you in the code section. So you can see that all the pen blocks are now available to me, but that's really important. Make sure you remember to add that extension. And you can think of an extension as being in a bit like a library, which we use in other programming languages, which adds extra code blocks that allow you to code things more easily, and you don't have to then hand code all of the information that you would need to be able to do the things that these blocks do. So that's how you add the pen tool to your work. Okay, so let's have a look at what we're going to be learning about in today's session. Okay, so this is Shape Calculator Part 2. Hopefully you joined me with Part 1 where we looked at how to use a flowchart for representing different shapes, and we then moved on to how we would use variables to create a shape calculator, and that's what we're going to be doing in today's session today. In this workshop you're going to learn about how you could convert an algorithm to a program, because of course the way that we create a program that a computer could run is to take the algorithm and convert it into code. We're going to be creating reusable code by writing procedures. We're going to learn how to use selection and loops within our program, and we're going to learn how to use variables. And finally, we're going to look at how we can use questions to collect input from the user of our program. So this today is going to be looking at the computer's turn. So previously we looked at how we would code a solution using flowcharts like this, and we looked at how to collect input from the user and then use that input to draw a different shape. And what we're going to do today is we're going to take what we've learned and we're going to develop a program that will be able to make the drawings for us. Okay, so jump into your Scratch program And you are going to start by drawing a square. So we're going to work out the blocks that we need to draw a square. Now for now we're going to do this just in sequence. That means it's going to be just one instruction after another. We're not going to worry about putting the loops in just yet. We're going to get it to work in sequence, and then we'll start to think about how we would add those loops in as we go along. So we're going to need to start with an event block. We're going to use the when the green flag is clicked block, and then we're going to use the pen tools. So the first one that we need to use is the pen down. Now you might remember this from when we did it in our flowcharts. We realised that we had to include the position pen on paper in our flowchart so that we knew, so the computer knows when to start drawing effectively. So that's what we've got in there. So we're going to use the same idea in our actual Scratch program. We've got that pen down there. And then we're going to start to get our Scratch cat to move. I'm just going to move him over to one side for a moment. And then we're going to go to the motion section, and we're going to use the move to get him to move across the page. And I'm going to set this to 100 steps. And then I need to get him to turn the correct number of degrees. Now the correct number of degrees for a internal angle of a square is of course 90 degrees. And we're going to repeat these two blocks 4 times, because we need to have 4 sides to our shape. Now what I've just done there, if you didn't know how to do that, is I right clicked on the first of the 2 blocks and then I clicked duplicate, and that just makes a copy of them. I could of course, if I want to, put them in one at a time as well. That's absolutely fine. You can do it whichever way you prefer. Just make sure that you select the same turn in the same direction as you did the first time. So you must have that same turn in direction the same each time. Okay, I think that's pretty much there. So now if we press the green flag, we should have Scratch Cat drawing us a square. There we go. So we've got a lovely square drawn for us there by Scratch Cat. Then what we might want to do is we're going to now move on to having a go at drawing a triangle. Okay, so what I want you to do is have a little think. I'm going to copy this code and I'm going to pop it into my PowerPoint so that you can have a look at it more closely. And I want you to think about what you would need to change if you wanted to turn this into a triangle. So I'm going to pop it in here, and then you're going to have a go at drawing a triangle instead. So what would the code be for drawing a triangle? Have a go yourself, and then once you're happy that you've got it correct, then I'll show you what I've ended up with and we'll see if it matches mine. So let's pop that up and we'll put that on the screen, and hopefully you'll end up with something the same as mine. So there you go, there's the code for creating a square. What do you need to change it to create a triangle? So what I'd recommend you do now is, if you need a little bit longer, is you pause the stream, because I'm going to go through the answer. But if you want to go through with me because you're not quite sure what to do, then that's absolutely fine as well. So I'm going to jump over and bring up my Scratch, and I'm going to show you how to adapt the code to make it into drawing a triangle. So first thing I'm going to do is I'm going to strip out one set of these blocks because I only need it to repeat 3 times. And at the moment, remember, we're doing this in sequence. We're not worrying about including loops in our program. In fact, what I'm actually going to do is I'm going to duplicate this whole block. So if I do a right click on it and go to duplicate, I can create a second version of the code. That way I can keep my original one and we can do a bit of work with that later on. And what I'm going to do is I'm going to just disconnect those blocks from each other. That way this code isn't going to run when I press the green flag. And I'm going to remove one set of the move 100 steps, turn 90 degrees, because we don't need to use that in our code for drawing a triangle. And I'm going to keep the moves the same because we want him to move roughly about the same size, same length of line. But instead of using 90 degrees, I'm going to change the number of degrees. Can you remember what we said the number of degrees it needed to be for drawing a triangle from last time? Let's have a little look on here and see if we can spot something that might help us with that information. Can you see it here? Turn 120 degrees. That's what we used previously. So let's see if that will work in our program. So hopping back across, and we're going to try changing the number of degrees from 90 to 120. Let's pop those in there. So all of the turns are going to change to 120 degrees. Okay, and then we're going to run our code. So we're going to press the green flag and see what happens. Yay, we've got a little triangle drawn inside that. Now, you might be looking at this and thinking, this is all well and good, but I can still see my square, but I don't want to be able to see that. So let's have a look and see if we can find the block we need to use for that. Let's go back into the pen tool blocks and see if we can find one that would be used to remove any drawings before we start with a new one. Can you see the one that we need to use? Well done, yes, we need to use the erase all. So we're going to pop that into the top. And now when we press the green flag, the very first thing it will do is erase all the original drawings and then put the pen down to do the new one. Let's have a look at that, what that looks like now. There we go. So now we've ended up with just the triangle and that looks much better. Okay, one thing we're going to do just as a quick little fun activity before we move any further, I don't really like having Scratch Cat on here. I don't think it looks all that great. I think it would be much better to have a pencil as our sprite for what we're doing today. So I'm only going to do a quick little activity to get you to change the sprite and turn it into a little drawing of a pencil rather than the Scratch Cat himself. So to do that, make sure you've got him selected. Go to costumes. And now what you could do is you could go down to the choose a costume option and go to the search and see if we've got one already built in. Let's go and have a quick look and see if we can find one already. So if we want an object, so let's see, I don't know if we've got anything that's going to be quite right. So I'm just waiting for it to load and then we'll have a look for a pen or a pencil. And if we've got neither of those, we'll have a go at drawing one ourselves. So I'm going to type in pen and see what we end up with. Let's have a look. Oh, looks like we might have something that's suitable. Just wait for it to load the images. Then we'll know if it's going to work. Yay, that pencil A is going to be perfect. So we're going to click on that pencil A. And that will bring in that as an extra image to use. So we're going to delete the original ones that we had because we don't need those. So we're going to delete costume 1 and 2. And the other thing that we can do is we can check to see where the centre of our image is. So at the moment, when we look at it, it's round the wrong way. We don't want it to be quite that way, so we need to flip it. So let's have a go at flipping it to make it face the right direction. There we go, that looks better. And the other thing that we need to do is to change where the middle of the image is. And I've got to remind myself how to do that in Scratch because it's moved around now. So some of the things that you used to do in a certain place isn't in quite the same area as it used to be. So just bear with me a minute while I remind myself how to do that. Let's see, is that an option? No, that's just the zoom in and zoom out. Let's see if I can find it. We want to basically choose the centre of the image so that we can say that the centre isn't right in the middle here, but it's actually the little pen tip down here. And I've got to remind myself how to do that because some things have changed in this version of Scratch and I can't remember how to do that. It might be easier to do it as a bitmap. Let's see if there's an option to do it in there that makes it easier. Doesn't look like it's easier, so let's leave it as a vector. I think we'll have to come back to that because I can't remember where it is in here, and I'll have to do a quick little look up and remind myself how to do it. But at least now we have a pencil rather than the Scratch Cat, which was going to look a little bit better anyway. Okay, so let's go back into our code. And we've now got two bits of code. We've got the code that will allow us to draw a triangle, and we've also got the code that's going to allow us to draw a square. So I'm just going to pop that across into that one, and I'm going to run the code again, and this time it will draw a square. There you go, perfect. And if I put it over here, put the instruction to erase all first and then put it underneath and then tell it to run that code, we're going to draw a triangle. Lovely. Okay, so I'm going to add that little bit of code to my presentation, and then the next thing we're going to do is you're going to see if you can work out how to draw a circle. That's what we're going to do next. See if you can work that one out. And once you've done that, we'll have a look at how we can make our code more efficient. So let me just hop over onto the presentation and we'll have a look at the code we've now created for drawing a triangle. And we'll have a look at the next question, which is how would you draw a square? Sorry, draw a circle, I beg your pardon. So there you go. So there is our code for a square. There is our code for a triangle. how would you go about drawing a circle? And once again, give yourself a bit of time. If you need some more time to have a go at doing this, then you can pause the stream and just experiment with creating that. But if you're ready to go through it with me, I'm going to go through how to create the circle shape in just a moment. So give yourself a bit of time if you need it. But if you're ready to go through what the answer is going to be, I'm going to be going through that with you next. Okay, so the first thing that we're going to do is, rather than having our code just in sequence, we're actually going to change our code slightly, because the way that it's written in sequence means that drawing a circle would mean we'd need to draw a lot of steps. And actually that's not going to be very easy to do, and we want a much more efficient way of doing that. So the first thing we need to do is change our code so that instead of using sequence where it's all just run in order, we start to use a loop or iteration. And you'll find the loops in the control section, and you'll find the one that we need to use is the one that has a repeat and it has a set number inside it. Okay, so before I show you the correct answer for that, see if you can work out what we need to do with our code. So we're going to need to use this repeat, and you'll need to use two of them because you'll need to use one per block of code, and you'll need to change the number inside the repeat so it repeats the correct number of times for each shape. Have a little think, see if you can work it out yourself, and then I will show you the answer. If you need to pause now before I go through the answer, then feel free to pause it. There's the pause if you need a bit longer, because we are going to go through the correct answer now. Pause if you need it. Okay, so the first thing we need to do is get rid of any excess code. So remember, when we looked at how we would do this last time, this is our triangle example, remember, we only needed to repeat these two instructions, but we needed to repeat them 3 times in order to draw ourselves a triangle. So this is what we're going to be basically representing in our Scratch program. So what we're going to do is we're going to pop in our repeat into our code. In fact, we're going to strip out the code we don't need first. So every time, so move 100 steps, turn 90 degrees. 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 First job, work out which instructions are repeating. And we can see that it's these 2 steps that are repeating. So we can get rid of all of the blocks after the 2 that's being repeated. And we can get rid of them just by dragging them over here on the code section, and that will delete them. Then we can put our repeat around those 2 instructions. Instead of repeating 10 times, we want it to repeat 4 times. Perfect for a square. We're going to just unsnap these 2 so we can use the erase all again, and we're going to pop them back together. And now when we press the green flag or we click up here, you can see it will draw us a square. Perfect. Okay, so what do we need to do to this bit of code? First job, remember, work out which instructions are being repeated. Very good, it's just those first 2 instructions again. Let's get rid of the excess, and then we're going to put our repeat around those 2 instructions. Perfect. And then we need to change the number of times it's being repeated. So in this time, we want to draw a triangle. So how many times does it need to repeat if we want to draw a triangle? Well done, we need to repeat it 3 times. So now if we unsnap this side and put the erase all onto this side, and then join it all back up again, press the green flag at the top, it will draw a triangle. In fact, it's an equilateral triangle. Very good. Okay, so that's working perfectly. So now we've worked out how to make our code more efficient by using iteration, remember, or a loop. Iteration is the correct computing terminology. I'm going to pop an erase all in the top of this one so I don't have to keep snapping it out of the other one. There we go. We now should be able to work out what we need to do to create a program that could draw a circle. As usual, if you need a bit more time, you can pause the stream now, have a little experiment yourself, and then come back to me when you're ready. So feel free to pause the stream if you want to, experiment and see what you can come up with, and then when you're ready, join me and we'll go through the correct answer. Okay, so let's have a go at doing this. So the first thing we're going to do is we're going to duplicate one of these bits of code. So we're going to do a right click on it and go to duplicate. We're going to pop that over here. And the first thing we're going to do is we're going to change the number of steps. Because we want to draw a circle, we don't want it to do such a large number of steps, because if we did a circle with 100 steps between each stage, we're going to end up with a circle that's enormous. So I'm going to change this just to 1 step, but I'm going to make it turn, let's try 1 degree, and then we're going to repeat it 360 times, and let's see what that looks like. Because remember, there are 360 degrees in a complete revolution if we turned all the way around. Let's see what that does. So we'll press the green flag and we can see it's drawing our circle. Let's watch it going all the way around. And we have a circle. Perfect. I'm really happy with that. Did you end up with the same solution for your code as I did? Ah, maybe you did, maybe you didn't. So the reason that this takes a little bit longer to run is because it's running these instructions 360 times. So it takes a little bit longer to run the code because it's more code. There's more of it to execute, and that's why we end up with the running like it does. Okay, so I'm going to have a look at what we're going to do next, and then we'll have a think about the next part of the program. So let's add this to our instructions. So far we have learned how to draw a square, we've learned how to draw a circle, and we've learned how to draw a triangle, and we've thought about how to make our code more efficient, and we've added the iteration in to our code so that we can make sure that it repeats the correct number of times in order to draw our shape. So if you remember last time, we said that we wanted to think about how we could start to combine these different shapes together. So that's what we're going to be thinking about next. So the next part of our instructions is we're going to have a go at drawing multiple shapes together. So what I would like you to experiment with doing is seeing if you can work out how to create a program, sorry, that will draw the 3 shapes on top of each other. So that's what we're going to have a go at doing next. So have a go, combine your codes together and see what you end up with, and then join me in a moment to see what I've done and see if you came up with the same solution as your first answer. So feel free to pause the stream now if you want a little bit longer to have a go at that. Or if you're ready, I'm going to go through my solution, my first solution, because when we are coming up with coded solutions for things, we don't necessarily go with what will always work straight away. We're going to maybe have a little bit of an experiment to see what works and what doesn't work. And then we'll see if we end up with the same idea. So my first thinking on having a go at doing this is that I will create my 3 shapes by running these bits of code one after another. So first thing I'm going to do is I'm going to have a little look and decide what parts of this I need to keep and what parts I need to get rid of. And I can see that I've got this erase all pen down at the beginning of each part of the code. Now I don't need that repeated every single time because that only really needs to be at the very beginning of the code that I'm writing. After that, I'd want it to draw my 3 different shapes. Now the shape at the top is the circle, so we want to do that bit of code first. So this is my code for the circle here. So I want to keep that at the beginning. Then I'm going to try putting the code for the, let's have a quick reminder of what we need, which order we're putting this in, because I've forgotten already. The order we're going for is a circle, followed by a square, followed by the triangle. Okay, so that's the order we want to put it in. So let's have a look at which bit of code would need to go next. So the next bit of code I need is this code here, which is the code needed for drawing a triangle. So let's pop that underneath the circle and then put the code for drawing a square at the bottom. Okay, so let's try that to start with. So it's going to take a little while to run because it needs to spend that time running the code for drawing the circle, but then you should see the triangle and the square fairly quickly. And I think I've done that in the wrong order. Let me just double check again because I have a feeling, yes, I've managed to look at the instructions, which was circle, square, triangle, and then put them in the wrong order when I selected the code. Really easily done. I'm sure that you've made mistakes in the past before, so don't worry if you make a mistake. It's all part of learning how to code. So I'm going to go back and put it in the right order. So instead of going circle, triangle, square, it should go circle, square, triangle. There we go. Right, that's in the right order. Okay, so now if I press this code, I should be able to see it start to run through the code and see what I end up with. So let's have a look. Okay, so we're just drawing the circle to start with, which is what we expected. Okay, still drawing the circle at the moment. Let's have a look at what it does after that. Then it drew the triangle and then it drew the square. Not in quite the order that we expected it to be in, was it? No, something definitely different is going on here, which isn't quite what we expected it to do. Okay, so what do we need to do? Have you got any ideas? So you can spend a bit of time experimenting yourself if you want to. As usual, feel free to pause the stream if you want to experiment yourself and see if you can work out what you need to do. Or you can have a go with me now and we'll talk through the next part of what we need to do. So completely up to you. If you want to spend a bit of time experimenting, feel free. Otherwise, we're going to have a go at doing this together now. Okay, so my next thought is I need to actually move the position of my pen before I do anything else. So that's what I'm going to have a go at doing next. So I want to move my pen from where it is so that it positions it in the right place for drawing the next shape. So that's what we're going to have a look at doing now. So we need to go back to the motion and we need to change the position of our shape. So at the moment, if I have a look at the motion, I can see that there is a go to X and Y. And that's what we're going to be using to change the position of our shape, our sprite. So the sprite at the moment is here, and that's where it starts from each time. So each shape is being drawn from that point. But we want to move it so that it starts the shape in the right position each time. So I'm just going to unsnap the extra pieces so that we can work out where we want it to start from to draw the next shape. So if we draw the circle, we can see where it will end up. Okay, so we can see it ends up there. Okay, so what we want it to do is to start drawing our next shape further down the page. So I'm actually going to just reset this slightly because I want to start my drawing of my circle higher up so that I can actually see everything in the right places. So I'm going to reset it and just send it off over there so I can see that it's starting in the right position. Okay, so it's drawn my shape, and then what we want it to do is we want the position of the next shape to start around about there, I think. So you can see we've now got a new X and Y position for our sprite. So the X and Y position is the position of the shape on the canvas, on this area here. We call that the stage in Scratch, in fact, so in the stage area. So we can see that it's at position X1 and Y4. So now, if we get this, which has got go to X1 and Y4, we can put that in between the shape so that it will start to draw that. Okay, the other thing we want to do is we want to make sure that this always starts at the right position, which was up here to start off with. So let's make sure we've set that as well. So we can see the X and Y position has changed. So it's now got minus 66, Y 110, and we want to put that in there as well. So let's try that now and see what we end up with. So press the we're going to press the block to run the code. So we can see it's drawing our circle. It doesn't matter if it disappears off the top of the stage area because we can see it coming back in the moment. We can play around with the X and the Y to get that right, and then we could draw the next shape. But we've got a bit of a problem going on. We can see that it's actually drawn the line between the two positions before it started to draw the next shape. We'll have a think about that while we go to the next shape. So we want to do the final shape, which is the triangle. So we want the triangle to start further down the page, about 100 pixels or steps further down the page. And we can see that the Y position should be 104 if we want it to be exactly 100 below, and we wanted to keep the X position the same, so it's actually underneath the original position. So we can put this one in and we can adapt it slightly to make it right. So the X is going to be the same as it was before, it's going to stay as 1, and the Y position is going to be minus 104, which is exactly 100 below where it was originally. And let's pop in the final bit of code to draw the triangle, and let's try that one out. So we draw the first shape. So we're sort of just finishing drawing the circle, and then it's drawn the rest of the shapes. But we can see we've still, as I said, we've got a little bit of a problem going on because we've got these other lines being drawn. Have you got any ideas of what we could do to stop that from happening? Very good. We need to use that erase between it and also tell it to lift the pen up and down in the right positions. So the first thing we're going to do is we're going to unsnap the repeat and we're going to put the go to right at the very top. So that happens as the very first thing that we do before we start to draw the next shape. We then erase any extra markings that we've made accidentally, and then we put the pen down to draw our first shape, which is of course our circle. Then we want to have a pen up before it moves to the correct position. That way it will lift the pen up, it will move to the position it needs to go to, and then it'll put the pen down before it starts drawing again. So that's what we're going to do in this section here to stop that strange line from being drawn, which is this line that goes from here to here, because we don't want that to happen. So we're going to go back into the pen section. We're going to do pen up, so we lift the pen, we do our movement, and then we put the pen back down again, and then we can draw the next shape. I'm going to zoom out a little bit so you can see all of the code. And then we're going to do the same thing again for the triangle. So we're going to do pen up, change the position, put the pen down again. That way we're not going to have the extra lines drawn in the wrong places. So let's try that now. So we're going to click here to run the code. So we draw our circle first. That's it, we can see it drawing the circle, it's just taking its time to draw it. And then it drew the other shapes. Okay, so they're not quite in the right positions. We can see that the triangle is a little bit too low down compared to the square. And also both of those shapes need to move a little bit more to the left. So we can experiment with that a little bit and get them to move to the right position. So let's have a little go at doing that now. So we're going to move the shapes across so they end up in the right position. And we do that by changing the X that we're using. So at the moment the X we're using is 1. And we know that's a bit too far over to the right. So we want to move it over to the left a little bit. So if we work out roughly where we want to move it to, which is probably for it to start, I reckon about there. So minus 22. So let's change the X position to minus 22 and then see if that works. And see, yeah, so see if that works. So we're going to run the code and see if that works. There it goes. Then that's a bit too far over this time, so let's try minus 15. So this is where a little bit of trial and error is a really good thing to have. So there's nothing wrong with a bit of trial and error until you find the solution that you're wanting. And let's try that again. So we're drawing our circle and seeing if the other shapes go in the right place. And oh, it's still not quite far enough over. So let's try, or is it? If I sit back a little bit further. Actually, that's not too bad. What I could do is moving everything down a little bit. So let's change the Y position to move everything down slightly so we can see things more clearly. Let's try 80 up there. We'll try a Y position of, now how much do we want to move it down by? I moved it down by, if I just Control Z to undo what I just did, then we can just double check what I just did. So it started at 110, so I took away 30. So if I take away 30 from this, which would make it minus 34, yes, minus 34. But I don't want to make it quite as far down as that, so I'm going to make it minus 30. No, minus 24, so let's try minus 20, I beg your pardon. And then let's change this one to minus, we don't want it to move down quite as far, so let's try minus 90 and see if that does the trick, just to bunch them up a little bit better. So again, I'm just thinking about the maths and experimenting with the numbers to find the solution that I want. So let's run that. Hopefully we can fit the whole circle in this time, which was the aim of changing the code slightly. Oh, it's almost in, isn't it? It just sneaks off the top, so maybe need to move it down another 20 just to get it in the right place. And so my square and my circle are now absolutely perfectly sitting on top of each other, but my triangle is too far up, so I need to move it down a little bit further. So let's try minus 100 for that one. In fact, we're going to move everything down by an extra 10, so let's make that minus 110. Let's make that minus 30, and let's make that 70. So everything moves down by 10 steps. Let's try that, see if that works. So the aim of this is to experiment with the numbers until we end up with everything fitting in. Oh, so close. Okay, we need to move it still a little bit further. We'll try another 10 in a moment. Just let you finish running the code. Okay. Oh, and nearly, very, very nearly. So let's try another 10, everything down by 10 again. So we'll try 60. And we'll try minus 40. And we need to move this down by a little bit further. So let's try minus 125 to see if that is enough to put it into the right position. Okay, fingers crossed everybody. Let's see if it works. So we just, oh, that fits in perfectly. Yay! Perfect. Yeah, so we've done that. Well done, everybody. So we've managed to get our code now to correctly draw our shape so they sit nicely on top of each other. But we have ended up with this great long program, which isn't very efficient, because we've talked about efficiency being about making the code as short as possible, and we want to actually change this now so that the code is shorter. So what we're going to do is we're going to have a go at changing the code slightly. In fact, I'm going to quickly show you how to do that with one bit of your code, and then you're going to see if you can experiment with making the code shorter and more efficient. Okay, so what we're going to do is we're going to take the code just for one of your shapes, and we're going to have a go at changing that to what is called a procedure. Now, we've talked about procedures previously in some of our other workshops, and a procedure, remember, is a named piece of code that carries out a few steps of instructions. So in this case, we're going to make this into the instructions needed for drawing a circle, so that's our circle code. So to do that, you're going to go to My Blocks, because you're going to create your own block, and go to Make a Block. And we're going to give it a name, which is going to be circle. And we're going to click on OK, because that's the code that we need to make a circle. And you can see we've now got a block that says define circle. And that means what is the code needed to draw a circle. And we're going to take our circle code and we're going to drop it into the code underneath. And as before, I'm going to duplicate my original code so that I can chop things out but have the original to compare it to. What I will do though is get rid of these extra bits I don't need at the moment. So there is my full original code, and what I'm going to do is I'm going to start to uncouple the bits I don't need in this bit of code, and we're going to take the code needed for drawing a circle and we're going to pop it in there. So now this is the code that we need to draw the circle, and instead of having to put the whole lot of code in, we can use our block that just says the word circle. So now we can just call the code. So we've defined the circle code, and then we're calling the circle code here. So now if we join them back up and we click at the top to run the code goes down to this point, it jumps over here to the code for the circle. It's now running the code to create the circle. There it goes, it's going round. That's it. And then once it gets to the end of the code, it will carry on from this point and it will run the rest of the code. There you go, and it's done. So what would we need to do to create the code block for drawing a square and for drawing a triangle? Have a little think. If you need to pause the stream now, feel free to pause if you want to, but if you're ready to move on with me, I'm going to show you how to do that now. So it's exactly the same process as before. We go to make a block, we give it the name, so this time it's going to be the square, and then click on OK. And you'll see the define square pop up over there. We're going to unsnap the excess code and grab the bit for drawing a square, put that underneath. So now we've defined the code for a square, so we can use the block that just calls that code now. Put that in there, and then we do exactly the same thing for creating the triangle code. So make a block, name it triangle, click on OK. And now we've got the define block for creating the code needed for naming our code triangle. Pop in the triangle code underneath, and then we can use our triangle block to call it when we want it. Okay, so let's try that now and see what we end up with. So click on the code. There we have it drawing the circle. That's it, that's the circle drawn. Then it's drawn the square, and then it's drawn the triangle. Now the advantage of doing it this way is because you can then move the block round to wherever you want to without having to worry about where the rest of the code was. So if I wanted to move the square and draw it somewhere else, I could just drag it around and move it to up here or anywhere else in the code. I can also reuse that block of code. So if I decided actually, once I've drawn my triangle, I then quite like to draw a square around that triangle, I can just pop the code in there, and now it will then run that square code automatically. So in fact, what I'm going to do is I'm going to tell it once it's drawn the triangle to draw the square and then the circle. So let's run the code and see what happens. Ooh, so we've got something really bizarre going on there. So that's created something quite different because it got a little bit confused somewhere, I believe. Oh, I know what I did. Did you spot what I did? I pressed the green flag here, so it's running this code and this code at the same time. So that's why we've got something a bit weird and wonderful going on, which is actually something we're going to go on to a bit later. So I should probably unsnap that so I don't accidentally do that again, and run the code one last time so it's actually in the right place. There we go. So we should now get the three shapes on top of each other, and then it should draw an extra square and an extra circle around our last triangle. Okay, so let's have a look what we end up with. Oh, so it's a little bit different to what I expected it to do because of where the position of the shapes were, but you can see it's done the circle, followed by a square, followed by the triangle, and then it drew the extra square and then the extra circle. But obviously because of the position of where the centre of the image is, that's where it is ended up with. Okie dokie. So let's have a look at how we actually make a shape calculator. So let's go back to our presentation and have a think about what we want to do next. So we've succeeded in creating our different shapes, and we've learnt about the term a procedure. Remember, that is a named sequence of instructions to be followed. So we've ended up with a lovely example of that in our code, where we've got the named different shapes, so square, circle and triangle, and we've then used the name of the code inside the actual main part of the program when we press the green flag, so it knows when it sees the bit of code that says square, it jumps to our procedure for square and it runs through that code. The next thing we're going to do is we're going to make it more interactive. So we're going to make a program that meets the following requirements. You have to enter the number of sides in the shape and the length of each side, and then the computer is going to calculate the angles required and draws the shape for you. So that is what we're going to do next. So I'm going to leave it on the screen for you. If you need to pause the stream now, then feel free to pause it. So there's the pause to remind you if you need to pause, because we're going to have a go at doing this next bit now. So this is what we're going to be moving on to, creating a program where you enter the number of sides in the shape and the length of each side, and the computer is going to automatically calculate the angles required and draw the shape for us. So let's have a go at doing that now. So I'm just going to come back out of the presentation, and the first thing I want you to think about is what variables you're going to need to use to create this calculator. Now you're going to have to create 3 different variables. You're going to need to use we'll think about what those 3 are in just a minute. So the questions I want you to ask yourself are, what instruction block is used to start? Where is the block to ask a question? And where is the block to set a variable? So what instruction block is used to start? Well, we know that. We use the green flag, don't we? The block to ask a question is in the sensing section, and the block to set a variable is in the variable section. And I'll show you where to find that in just a moment. The variables that you're going to need are these 3. So maybe you've come up with this. The angle that you're going to need, the number of sides, and the length of the sides. So we're going to be creating 3 variables for our program. So let's do that first. Let's jump onto our presentation. Nope, onto Scratch. That's it. And we're going to have a go at doing that first. So I'm actually going to start a completely blank version of Scratch before I move on, because I don't want to reuse anything that I've done here. I'm going to start from a new blank canvas, so to speak. So I'm going to type in scratch.mit.edu, and I'm going to open a blank Scratch project, and we're going to have a go at creating our Scratch calculator, our shape calculator. So just waiting for that to load for a moment. There we go. And first of all, I'm going to create my code. My variables, I beg your pardon. I'm going to create my variables. So remember, we said there are going to be 3 variables. The 3 variables are going to be, let's pop them back on the screen to remind us, angle, number of sides, and the length of the side. That's the 3 that we're going to need. So we're going to do that as our very first thing. So we're going to go to variables, and we're going to go to make a variable. And the first one is going to be angle. It's for all sprites, and then click on OK. And you'll see it pops up here. If you don't want to be able to see it on the actual page, you can get rid of it by clicking on the tick. Click on make variable again to create your next one, which is number of sides. Now I'm going to use something called camel casing for this. That just means that every new word starts with a capital letter. There we go. So number of sides. So the first word is all lowercase, and then each new word starts with a capital letter and there's no spaces. And that's called camel casing. And it just means you can read it quite easily. So then I click on OK. And the last one is the length of side. So I do make a variable, and it's going to be called length of side. Okay, now I have those instructions. The next thing I need to do is start to build the code that's going to use them. So with this point, we're going to do a little bit of abstraction. We're going to work out what parts of our original code are unnecessary. What parts do we not need to use? So let's have a little look at the code we created for drawing our different shapes that we did earlier. So we've got the move, we've got the turn, and we've got the repeat. So those instructions are the same. The thing that's changing is the number that's inside the little oval on each of the shapes. So that is where our variables are going to go. So that's what we're going to need to recreate. So we're going to need a repeat, a move, and a turn, and we can use those again in our new program. So we're going to go to motion, and we're going to grab ourselves a move and a turn, and we're going to go to the control section to get ourselves a repeat. So those are the 3 instructions that we're going to need to use each time. And the move's not quite gone in, so I'll drop it in the right place. There we go. And we're going to use the events, and we're going to use the when the green flag is clicked. And you might notice that we don't have the pen tool blocks down here at the moment, so we need to add those in again. So we're going to go to the add extension, and we're going to add in the pen, and we're going to pop in the erasal, which we realised we needed to use last time, and we're going to use the pen down. Okay, so at the moment, if we run the code, Scratch Cactus does exactly what it tells it to do. So at the moment it was repeated 10 times, so it was 10 steps and 15 degrees, and that's as far as we got. So what we need to do is start to put in the rest of the code that allows the program to be run based on these variables. So where do they need to go? So let's have a look. So the number of sides needs to go in the repeat, because if we look at on our code that we used earlier, it was the repeat that told us how many sides the shape has. So we're going to go back into the variables section, and we're going to find the length of side variable, and you can tell it's the variable because it's the shape that fits into the block. So we're going to pop the length of side inside there, and we can set the length of the side by using the set block. Now we're going to pop that right at the very beginning of the code, and we're going to use the set number of sides, and we can put in how many sides we want our shape to be. So let's try putting 4 to start with. And we can so the next instruction we've got is the move instruction. So that's how long the length of the side is going to be. So the one we want to use is length of side. We're going to again put that inside the move, and we need another set block to set the length of the side. So let's change the angle to length of side, and we can put in how long that's going to be in there. And finally we have our turn and a number of degrees, so we use our angle for that, and we're going to set the angle at the beginning of the program again. And if you remember, the angle needed for a square is 90, because we're going to start with a square because we've got 4 sides. So let's have a go and see if that draws a square. Yay! Oh, but what's going on now? He's still drawing. He's drawing forever. Can you see where it went wrong? I can see where I went wrong. I've set accidentally the repeat to length of side and not to the number of sides. So that needs to come out and change it over. So it's easy to make a little mistake. Don't worry. If you make a mistake, you can then correct it and then run your code and just make sure it then runs correctly. Ooh, there we go, sorted. Okay. So the next step is to make it so that the person using the code can type in what they want. So every time you run the code, you're going to get a different shape based on what the person has input into the program. Now to do that, we are going to use the ask block, and you find the ask block in sensing. So go into sensing, go in and get the ask block, and the ask block needs to go 1 above the number of sides, and instead of asking what's your name, it's going to say how many sides. And instead of having the number of sides set to 4, we use the answer from that question. Let's try it now and see if that works. So we're going to press the green flag to run the code. How many sides? Let's go for 3 and then press enter. But that's not working quite as it should do, is it? So we need to use this question of how many sides to help to calculate the angle. So what little bit of maths do we need to do to calculate the angle? Yes, so we need to do 360 degrees divided by the number of sides. And if we use that every single time, then it means it's going to draw the shapes that we want to use. So let's pop that in now. So we're going to do operators this time. So we're going to go into operators, and the divide symbol, when we're talking about programming, is shown. Whoops, I've just gone past it. It's jumped down the page. Is this shape here? Can you see it's got like a forward slash in the middle of it? That's the shape. That's the symbol that we use for divide when we're talking about programming. Incidentally, if you want to know, the symbol that we use for multiplication, for timesing, is the star, a little asterisk there. So, but we don't need that for this one, but just so you know for future reference. So we're going to do the number of sides divided by 360, and that will give us the correct angle every single time. So we're going to pull in from our variables. We can now just use the number of sides variable because we've set it up here. We've set the number of sides to whatever they've typed in as an answer. So number of sides divided by, whoops, 360. Why 360? Yeah, because a complete revolution, if we imagine, if you turned all the way around, it would be 360 degrees. Perfect. So we're going to pop that into the angle. Okay, so let's test that and see if it works. So if we press the green flag, it should ask me how many sides. Let's try 3, and it should, fingers crossed, draw us a triangle. Oh, that didn't quite go to plan either, did it? So what's going on there? So let's see if we can work out what's happening. Let's do a little bit of a calculation, work out why it's not working. Yeah, we got it the wrong way round. We put it the wrong way round in the calculation. Well spotted. So we need to swap those over. So we need to do 360 divided by the number of sides. Let's try that again. So you can see it's easy to make little errors in your code. Don't worry, you can then experiment with getting them right. Another thing that you might have noticed, that the angle was really bizarre up here because we put the instructions into our calculation the wrong way round. So let's try it again. There we go. So he's actually drawn it. It's actually disappeared off the top of the page. So let's have another go. So how many sides? 3. There we go. Perfect. We've ended up with a triangle this time. So that's working perfectly. So let's try it again one more time. Let's try typing a different number. Let's try an octagon. How many sides does an octagon have? It has 8. Yeah, well done. So let's pop 8 in and we hit the enter, and we've ended up with an octagon. That's working really nicely. But what if we wanted to make different size shapes? Yeah, so we need to use that ask again. So let's go back into the sensing section, find the ask, and we're going to pop the ask in a second time just in here. It's important to make sure you put it after you've set the number of sides, because otherwise it would overwrite the answer, and we don't want it to overwrite it because we want it to be a new question after you've set the number of sides. So we want to ask what length of side. And we're going to set that to the answer again. And now we should be able to set different sizes. So let's move our scratch cat so we can see and draw our new thing. So how many sides? We're going to go for, let's go for a pentagram this time, 5 sides. Excuse me. And we're going to go for 50. So we get a little small 5-sided shape. Yay, that's working perfectly. Okay, so that is pretty much it for today. We have learnt loads. We've learnt about how to create shapes. We've experimented with moving the shapes around different parts of the page. Excuse me. Different parts of the stage area. We've learnt about how to create procedures and create different shapes based on procedures and then run them at different points in the code. And then we've moved on to using variables and actually creating a shape calculator that can draw different size shapes, different size shapes, and also different types of shape by altering the number of sides and the angle for each shape it's drawn. What could you do to take this further? Let's have a look at what you could do. Okay, so here's a few ideas for you. So what could you do to adapt this program? You could have a go at drawing some abstract art. You could write a program where the art changes every single time it's run. You could have a go at writing a program that draws your favourite Pokemon character. And here are the 3 ideas of what you could do. So creating an different abstract art, so that every time the program's run, the art changes. You could write a program to recreate the picture that you drew at the very beginning, and see if you can create a program that recreates it using input from the user. So the user will input the length, the size, and the angles. You could have a go, as I said, at writing a program that draws your favourite Pokemon character. So there are some ideas of how you could take and extend your program further if you'd like to. Okay, so that's pretty much us for today. You've learnt about how to convert an algorithm to a program. You've learnt about creating usable code, reusable code by writing procedures. And you've also learnt about how to use selection and loops in your program. We then moved on to how to create variables, and we used questions to collect input from the user so that we could change those variables as our program was being run. Very, very well done for today. I hope you've enjoyed that. As usual, I'm going to jump onto onto Twitch now and just give people the opportunity to ask any questions that I might have, and then I will go through a sneaky peek of what to expect for next week. So I'm just going to jump in onto the chat and give you the option of asking any questions. So if you have any questions, please ask them now. Just wanted to show you how to find the centre of the image and just make sure that your icon that you're using for drawing your shapes looks like it's drawing, so that you can actually see the pencil is on the line. And the way you do that, as I said earlier, it's moved from where it used to be in Scratch. It used to be a little bit simpler than this. So now what you do is you go to costumes. You can see I've already selected costumes and I've got my sprite selected. I'm going to click on the little plus magnifying glass to zoom right in. You need to zoom right into the image until you can see this icon here. That shows you that's the centre of the image. Then all you do is you move the shape so that the part of the shape that you want to be the centre is on top of that little crosshair. And once you've done that, that will mean that the shape is in the right position. So you can see now the little pencil, the actual nib of the pencil is now sat where I want it to be. So if I run the code now, it will draw the shape. You can see it actually looks like it's drawing the shape, so it's in the right position. So that's how you make sure that you centre your image. So go to costumes, click on the little plus icon here in the little magnifying glass and zoom right in until you can see the centre of the image, and then just move the sprite to the position that you want it to be, so that the centre of the image is positioned at the right part of the sprite. And I'm going to give you a sneaky peek of what to expect from our very last workshop of the summer, which is next Tuesday, and I'll show you that now. So if you're interested in joining me on our very last workshop, we are going to be doing a Eco Gamer workshop, and this workshop is looking at how you can create eco-friendly packaging and then create a advertising campaign around that packaging to really tell people about how the games industry can create packaging that uses much less plastic, which obviously is then much more planet friendly. And that's what we're going to be doing next time. So do please join me. We have a very special guest for that presentation. So do join me next time for Eco Gamer if you're interested. So I've had another look at the feed. I can see there's no questions in the feed from today. So thank you very much for joining me. I hope you've enjoyed today's workshop. Please remember to check out our YouTube channel for more follow-along activities. If you've got any questions or feedback for me, please email dsh@ukie.org.uk. Now, we'd love to see you learning computing at home with Digital Schoolhouse. Parents and guardians, please feel free to share any images or videos using the hashtag computingathome on Twitter or on Facebook. Also, for those of you who love writing, Digital Schoolhouse have launched a creative writing competition, which you can find out more information about on our website. If you're the parent of a primary aged pupil and are interested in finding out how the Digital Schoolhouse programme can help with your child's school, you can find out more information about the programme on our website, digitalschoolhouse.org.uk. You can find our contact information in the section below or at the end of this video. Lastly, I wanted to say a huge well done for taking part today. I'm Estelle and I look forward to seeing you next time.